Test parameterization allows us to run the same test more than one time with different data sets. It is a data-driven test type. Running a test using one input value is good, but there are times when it is better to have more than one input value. In this session, you will learn how to parameterize a test function with one decorator, parameterize a test function with two decorators, parameterize a Pytest fixture, and run the test with more than one browser. Our AUT, application under test, will be from LambdaTest, and it is a Selenium playground. The page is simple form demo. We will enter two values in the enter A field and enter B field. For A, we write the number 10. And for B, we also write the number 10. Then click the Get Values button. Finally, we will assert the total value of 20 after adding A plus B. Let's copy the URL. Now for the test script, we will parameterize our data sets by passing in different values to a test function with one decorator. In the IDE, let's create our Python file by right-clicking Demo Pytest, which is the package. Select New Python file, and the name will be test underscore parameters. We're going to create our test from Selenium. Import WebDriver. Also from Selenium.WebDriver.common.by. We're going to import the by class. Now, to use the parameters, we will use the @pytest.mark decorator. Now, it is followed by Parameterize, but we also need to import Pytest. And after importing Pytest, let's go ahead and add the first argument. And the first argument is the parameter name. So we add quotes and a comma. The parameter name can be one parameter or more than one parameter name. In our case, let's add num1, comma, num2, and expected underscore total. Notice all of the parameter names are within the double quotes. That's why it is still the first argument. The second argument is values we pass into the first argument. They are located within the square brackets. And let me modify how we're going to set up our values that we pass into the parameter name. The first data set is a list of tuples. So I'm going to add parentheses, and within the parentheses, I'm going to add some quotes. Then pass in the values of 25, comma, 25, and also pass in 50. Now these values is what we expect the parameter name to take in. For example, num1 would take in 25. The second 25 would pass into num2, and expected total takes 50. Now, the expected total is 50 because 25 plus 25 is 50. For the second data set, let me bring this over some. For the second data set, let's pass in values of 10, 10, and how about we pass in 30? We know 10 plus 10 is 20. Therefore, the expected total of 30 would cause this test to fail. The final test, and let's also make sure to add in the comma at the end of each tuple. For the final data set, let's pass in values of, how about 30, comma, the next one will be 40, and for the expected total, let's make that 70. Now, I mentioned that these parameter names will take in the values of what we pass in as a data set. So each value will take three, each parameter will take three values. Num1 will take 25, 10, and 30. Num2 will take 25, 10, and 40. For the expected total, it will take 50, 30, and 70. After parameterizing our values, let's create the test function. And the test function is created by defining the function name. And the function name will be test underscore LambdaTest to input underscore fields. At this point, we pass in each parameter name into the function signature. They must be spelled the same way. So num1, we pass in to the signature, and the same for num2, followed by expected total. Now, when it comes to our test script, we're going to pass in, we're going to create our driver instance. And that would be driver equals WebDriver dot Chrome. My typing is not going good, but let's hope it get better. Now, after creating an instance for WebDriver Chrome, next we're going to maximize the window, followed by loading the application with driver.get. Then paste in the URL. I forgot that I copied num1 and passed it into the function signature. So let's go back to the AUT and copy the URL. Bingo. Now, let's find the elements. Inspect the first field, and let's see what it have as the value for us to find. It has an ID value of sum1. Let's inspect enter B field. It has an ID value of sum2. Cool. How about we inspect the get values button? It does not have an ID value, but know what? We can still find this here by using the get values text. So I'm gonna hit Control F, and let's search for the element by writing 2 forward slashes, button, square brackets, text, parenthesis, equals the single quotes, and within the single quotes, let's pass in the text, which is get values. Bingo. We found the element. Now I'm going to copy the value, then go back to the IDE. In the IDE, let's find the first field by writing driver dot find element by ID. And the ID value was sum1. And we're going to send keys. The keys we're going to send would be the parameter of num1. Bingo. Now, the second one, we're going to use, I almost copied line 16, but we need to use that for the get values button text. So we're going to find it by writing by ID. Sum2 is the value for ID. Send keys, then pass in num2. For the button, we write driver dot find element by XPath. And I'm going to place this value on the next line. Then paste. Oh, I copied. Maybe I did not copy. I'm not sure. But let me go back and copy the value. Or maybe I end up copying num1. I'm not sure. But the XPath value, we placed it. And for the button, we click. Now, we are finished with adding A and B, and we're going to click the button. So we finished that part. Now, let's go back and we're going to inspect the message or the value for 20. Inspect 20, and it has an ID value of add message. Let's make sure that it is unique. Hashtag add message, yes. So let's go back to the IDE, and we're going to write actual total, because this is the web element. We find it with driver.find element by ID, then paste in the value. And now that we paste in the value, we want to get the text. So we write dot text. Now we verify by asserting if the actual total equals expected total. If they do not equal each other, then we want to return a message that says actual and expected totals do not match. Bingo. So now we are finished with this test function. Next, let's run from the IDE and the terminal. Let's start with the IDE. So I'm going to click this play arrow button to run, because I want to show you how it looks in the run window. That's the second iteration and the third iteration. Bingo. Each iteration shows all of the parameters. The first iteration shows 25, 25, 50. Second iteration shows 10, 10, 30. And the third iteration shows 30, 40, 70. The number of collected items is 3. Although there is one test function, we see the failure has an assertion that displays expected 30, but actual 20 after adding 10 plus 10. Okay, let's run this same test through the terminal. And we're already at the package of demo Pytest because I changed the directory. We run the test by writing Pytest test underscore parameters dot py. And let's see what the terminal returned to us. Bingo. The short test summary info section shows 1 failed, 2 passed in 11.21 seconds. We see which one passed. We see 25 plus 25 equals 50 pass, 30 plus 40 equals 70 pass, but 10 plus 10 equals 30 failed. And it shows that it failed for the same test function that passed for the other two. Also, we see assertion error. Actual and expected total do not match. Now, let me go back to the IDE and put expected totals do not match. And that's pretty much it for the short test summary. Now, you may not see the short test summary section, or you may not see other information. That's because in the pytest.ini file, I added these arguments, RA and V, so we can see more information. So if you do not see this information, feel free to add it to the end of your Pytest command, and you will see those add ops or those arguments. Now, that's it for the Pytest part of looking at how to add for one test function with one decorator. Next, we will look at one test function with two decorators. And going back to the IDE, we're going to look at the two decorators, and they allow us to input values that do not depend on each other. For example, for our test function with one decorator, the expected total parameter depends on num1 and num2. However, in this next example, I'm going to define a test where they're independent of each other. And the test would be called test raising base to power. And let me make more room by bringing this up some. Now, the calculation is going to use base and it's going to use exponent. By having the base calculate to the power of exponent and assign it to result. Bingo. Now, we're going to assert result equals math.pow. Then pass in base and exponent. Make sure that you import math. At the top, we see import math. After importing math, let's go ahead and make sure we have these parameters set up. For one decorator, we wrote Pytest.mark parameterize. However, for this decorator, we're going to write at Pytest.mark.parameterize, but we're going to pass in base. Now, the values are going to be 1, 2, and 3. Notice we only have one parameter name for this decorator, and that parameter name is base. However, in the previous test function, we had 3 parameter names. For the second decorator, we're going to pass in exponent as the only parameter, but the values will be 4, 5, and 6. Now, the base and exponent parameters are independent of each other. If we wanted to, we could make them dependent, just like num1, num2, and expected total. But I just want to show you this part with two decorators. Pytest will create all possible input combinations of exponent and base. There will be a combination of exponent 4 with base values of 1, 2, and 3. Exponent 5 also has a combination with base values 1, 2, and 3. It's the same with exponent 6. The base combination values will be 1, 2, and 3. Therefore, it should be a total of 9 input combinations. 3 values for base and 3 values for exponents. 3 times 3 is 9. Let's look at these combinations by writing Pytest, 2 hyphens, collect only. After collect only, we add the file name, which is test_parameters.py. And let's run. The collect only argument find files, test classes, and the test functions that will be executed. We see the terminal shows 12 tests were collected. 3 from test 1 and test function, the second one has 9. And those combinations are 4-1, 4-2, 4-3, 5-1, 5-2, 5-3, 6-1, 6-2, and 6-3. So that's how we use and look at the decorator with two decorators. Now, let's run. I'm going to clear this and then execute the command for Pytest test underscore parameters and watch how many tests are collected. 12 were collected, as we expect. And only 1 is expected to fail. Yes. 1 failed, 11 passed in 11 seconds. Okay, so I demonstrated this concept in a group testing with marker session. And that was the add ops part on why we see the short test summary. That's it for parameterizing our test with 2 decorators. Let's parameterize our Pytest fixture. Go back to the IDE right quick. And if you want more info about the Pytest fixture, then you can check out the previous session where I kind of explain the Pytest fixture, because that's what we're going to do next. By creating a new file, I'm going to right click demo Pytest, new Python file. The name of this file will be test underscore parameters underscore 2. Let me also change the other file to have 1. Bingo. Now, with this here, let's start by importing Pytest. And from Selenium, we import WebDriver. Also from Selenium, .WebDriver. Let's import common.by for the by class. The plan is to execute our test on more than one browser with the same Pytest fixture. The params equal Chrome, Firefox, and Edge. So the input values are Chrome, Firefox, and Edge. We define the function name as initialize underscore driver. Pass in request to the function signature. The function is called initialize underscore driver because initialize means to set the starting values at the beginning of the program. Also, initialize means to clear the previous data. Therefore, the fixture, this fixture will access Chrome, Firefox, or Edge if request.param equals any one of the input values. Let's start with Chrome. We create an instance for the required browser. Driver equals WebDriver.Chrome. Do the same for Firefox and Edge. So for that, let's write elif. Elif means else if. If request.param equals to Firefox, then we create an instance for Firefox. by writing driver equals WebDriver dot Firefox. Now, when it comes to Edge, I'm going to copy the one for Firefox because this session, my typing is not going good. Replace Firefox with Edge in both places. Bingo. So if the param value is Chrome, then WebDriver for the Chrome browser is initialized. It's the same for Firefox and Edge. They'll also be initialized if request.param reads Firefox or Edge. Next, after we create the instance for Edge, we're going to write request .cls .driver equals driver. Request .cls is a test class that uses the function containing our test. Let's also print the browser by writing request.param. So we see the input browser name. Our code is going to, let me add this comma right quick. I see the red lines. So the code will yield, and that's the finalizer. So let's print close driver. And we close driver using Selenium's close command. Now, at this point, we have finished parameterizing our test with more than one browser. Let's go ahead and run our test with more than one browser. Go back to the IDE. And in the IDE, we're going to begin with using the fixture we just parameterized by writing @pytest.mark.use fixtures. We pass in the name of the Pytest fixture we want to use, and that name is initialize driver. So now we pass in that name within the quotes. We're going to create another class, and that class is called base class. Then we're going to pass in the keyword of pass. Also, we're going to create another class, and that class will be called test because it's going to test the drivers. Let's pass in the base class. Base class is the parent class, which is also known as superclass. Let's tab. Make sure to add some space because now we're going to define the function name. The name will be test multiple browsers. Self is the parameter name. Next is to load the application by writing driver self.driver.get. And let's go back to the AUT that we're going to use for our test script. Because our test script will load the page, find the header Selenium Playground, then verify the header. Let's copy the URL so I can paste it in this git command. And start by inspecting the header. We see that it does not have an ID attribute. We see it has an H1 tag name. If I scroll up the page, the div ancestor has an ID value of 2_next. So let's use that to find our element. And we find it Let's use CSS selector and not XPath. Div is the tag name. The hashtag represents the ID attribute. Let's paste next. And we found the ancestor. Now we find the H1 tag with the space, H1, bingo. Let's copy this value. Go back to the IDE. Then write header equals self dot driver dot find element by CSS selector. And let me insert a new line so we can place this new value for CSS selector on the next line. And we are going to get information from the application under test. So we write text. Let's also print header yes, and pass in the variable. Last step is to assert header equals Selenium playground. And now that we have the Selenium playground, the next step, we're going to run the test. So let's go back to the terminal, clear this information, and write Pytest test underscore parameters, this time _2. The info section should show for Chrome, Firefox, and Edge, and all three should pass. Here's Firefox, and that was Edge. The print statements show browser Chrome, header Selenium playground, close driver. That's the first iteration for Chrome. The next iteration is for Firefox, and we see browser, Firefox, header Selenium playground, close driver, bingo. Now for Edge, we see the browser is Edge, header Selenium playground, close driver, and the short test summary info section shows all three iterations pass. Let me show you one more concept, and that's with the conf text.py file. I'm going to right click the project, Pytest tutorials, new Python file. The name is conf text, CONFTEST. Okay, so the purpose of this file is to provide a fixture for the entire directory. Therefore, any test function in this whole project can use the Pytest fixture. So when I go to the initialized driver, that's the fixture name. I'm going to cut and paste this whole fixture so the project does not have two fixtures with the same name. So when I cut this information, go to conf, and know what? This is not correct because it has conftest.html. We need conftest.py. So I'm going to delete this. Well, let me show you the difference before I delete it. Right click the project, new Python file. And I thought I did this the last time, but maybe it was not the correct one. Bingo, this is what we need. conftest.py. Let me delete HTML because that's not what I was intending to use. And I'm going to paste this information. After pasting the information, let's go ahead and import our classes that we need. Import Pytest, import WebDriver, and select Selenium.WebDriver, and I believe that's it for our import statements. Now, let's run again, because the purpose is to show you how it can be added to conf test so all tests can use this same fixture, because we saw how it passed and worked when I put it inside of the file But now, go to the terminal, and I'm going to run the same command. And I expect to see the same results. The print statements and the short test summary info section should show all 3 tests passed. Bingo. We see iterations for Chrome, and it passed, Firefox passed, and Edge passed. That's it for this session on how to parameterize a test in Pytest. Next is skipping and stopping a test. If you would like to learn more, then make sure to follow the blogs at www.LambdaTest.com/blogs and community.LambdaTest.com. In addition to the blogs, you can earn a certification at www.LambdaTest.com certifications. Get educated, get recognized.